This video series provides an overview of the electrical characteristics of motor starters. The series of 4 videos include 1. Characteristics and differences between relays, contactors, and motor starters. 2. Motor current and overload protection. 3. Motor current overload sensors, and 4. Starter auxiliary contacts. Conductors and overcurrent protection in motor circuits must comply with the National Electrical Code. Motor nameplates give detailed information. Information such as frame, service factor, volts, amps, RPM are typically listed on the motor nameplate. This information is vital for proper circuit design. Motor current is used in concordance with the National Electrical Code in determining the conductor size and the size of the overcurrent device to the motor. The motor nameplate current is the current of the motor when under a full load. One of the major factors in motor circuit design is the consideration of the motor's starting current. The starting current of an induction motor may be many times the value of the starting current. The starting current may last only a few seconds, however, this surge current can affect the overcurrent device. The starting current of a motor may cause breakers to trip or fuses to open. The initial surge current can be up to 8 times the nameplate running current. The starting current may last several seconds and may affect the overload protection of the motor. Proper circuit design is necessary to prevent unwanted circuit failure or damage to the motor. In the example, the motor nameplate identifies the current at 34.9 amps. A breaker or fuse to the motor may fail if not designed without the starting current in mind. On the other hand, a breaker or fuse size to allow for starting current may allow excessive current to the motor after the initial startup. In the example shown, the motor is protected with a 50 amp fuse. A standard 50 amp fuse will fail due to the initial startup current of the motor. The motor will not start. In this example, a 250 amp fuse is placed in the circuit to allow the initial startup current to the motor. The motor will start since the fuse allows for that amount of current. However, during the motor's normal operation, the fuse may allow excessive current that may damage or destroy the motor. Proper motor circuit design requires an understanding of the National Electrical Code. The National Electrical Code dictates not only the conductor size to the motor, but also the overcurrent rating for the conductors. Notice in the code chart, the allowances for increasing the current ratings of both fuses and breakers. Special fuses are available that allow for both start current and run current. The National Electrical Code specifies conductor sizes and overcurrent devices and sizes. The National Electrical Code must be followed for all motor circuit designs. Fuses and breakers must be designed to allow for not only conductor protection, but also initial startup currents of induction motors. The next video will examine how motor starters, not breakers or fuses, protect motors from overcurrent conditions.